This is my talk about how to write developer-friendly code. We're going to see what I think that means. I'm Adrian. For those of you that don't know me, I present here sometimes. I'll explain in a second mostly why. I've been working for over 15 years, I think, mostly product companies. I'm currently a principal engineer at Readability. I used to write articles on my blog a few years ago, but I don't manage to make time for that anymore. My main focus is, of course, front-end. That's why I'm here. And it's more like platform engineering, developer experience, front-end architecture, and things like that. And today we're going to look, like I said, about how to write code that's easy to read. My last talks were about technical leadership and how to be a senior developer. And a talk from last time, that one gave by Tolin, inspired me to try to create a talk with like code samples on it and actually show some code and talk about how you write that code. And like Anka mentioned, if anyone else wants to give a talk, please talk with Anka, apply on our website. It may sound like it's, oh wow, I have to apply on the tim.js website. I guarantee you it's like 99.99 chances you'll be accepted if you apply, because there are very few people that apply, so don't think that it's that hard. If it's your first time, or if you want more information, you can ask me, you can ask Anka, you can ask Andrei. All of us are more than willing to share whatever we know about giving talks, and I can guarantee you it's a skill that you want. That's why we're doing it, partially because we want to develop these skills for ourselves, and partially because, well, when no one else wants to present, we're doing it. So if you're tired of seeing me or Andrei presenting stuff, please sign up and we'll help you to give a talk. Okay, let's get back to the presentation from this evening about how to write code that's easy to maintain. First, before we look at some things about how we can do this, let's try to briefly discuss what do we mean by good code. We can talk about it for like the next few hours, because it's not something like very clear. It's not like have these three things, and if you achieve them, then your code is good. We're going to focus on two of them. First, it needs to be correct, right? I mean, your code needs to do what it has to do. You test your code. You can write tests that verify that your code does what it has to do. We have QAs that write more tests, for example, end-to-end tests, or they can do manual tests, and then you have product managers that can check that indeed the feature does what it's supposed to do. And in the end, you have users, and the users will tell you pretty quickly if the code doesn't work as they expect it to work. So this is not disputable. It's not like a range or gray area. Either it does what it's supposed to do, and it's correct, or it's not correct. The second important thing about good code is that it has to be easy to read. We're going to look at the second why. But this thing with easy to read, it's not so black and white as correct code, because easy to read can mean different things for different people, from different developers, from different teams. So it's a bit of a gray area to put it like that. And whenever we write code, it's like the computer knows how to execute it anyhow. It doesn't matter. But it matters for us because we end up reading it a lot of times, usually. Or if not us, probably other people that end up maintaining what we are doing. And probably a lot of you have seen a lot of examples. Let's look at a few of them. This is very simple. It doesn't necessarily look at something is wrong with it, but without any context, it might be a bit unclear, or it might take you 10 seconds longer to understand what this one line of code does. It's formatted on 2 because it needs to fit on the slide, but we can say it's a one line. We can see maybe this. At this point, you maybe try to figure out that, okay, this is not that easy to understand. It's still correct, still executable, but it's not that easy. Or maybe something like this, which a lot of you might have seen or used in your code. It's formatted a bit weirdly because, again, it had to fit on the slide, but it tries to get the status for a user, and in time we kept adding, and now it's like, okay, I can understand what this does, it still works, but maybe I don't want to touch it, or I don't want to like refactor this part. Or again, I can show you countless examples. This might be a bit weird. You can understand what it does if you spend enough time. But yeah, it's not that easy without any kind of context. Now, we can write code like this, but we can ask ourselves, well, why is this important? I'm paid to do my task. My manager will complain if I haven't finished the task. It will not complain that the code is not easy to read, usually. Well, it's important because, for example, in 3 weeks or 3 months or 4 months, you'll have to change that code probably. And then you're like, this guy, and you're like, what the hell, what am I doing here? Why do I wrote the code this way? How can I know, make it easier to understand? And it might not be you, but if you don't want to do this to yourself, why would you do this to one of your colleagues or someone else that has to maintain your code? And like I said, in 3 or 4 months, we can get to that part, and it increases the time to fix a bug, or increases the time to add a new feature, or if you get a new colleague, it increases the time to onboard him, because you cannot just tell him, okay, this is our general architecture, here is some of the implementation, because he's going to look at the code and he's not going to understand anything, and then you're going to try to help him, and so on. So the system becomes harder and harder to maintain. And usually you get to a point where either one of two things happen. First, it's so hard to maintain, to add new features or to fix bugs, that it takes you, I don't know, 1 month to add a new simple feature, something that looks simple. Well, it might take you 5 days to fix a bug. I think most of you have heard of cases when popular SaaS software were down for 3 days because they were trying to fix a bug or some infrastructure problem. And it becomes harder and harder to do it. And another company can come up with similar product, maybe without all this, let's call it technical debt or code that is hard to read, and then they can build features and add new stuff way, way faster than your company can, and then, well, you'll have to switch jobs, or you won't have a job because your company will no longer be in business. The other end to this slowly decay of code is that you reach a point where it's so hard to do things, and you decide to do a rewrite. And yes, we're developers, most of us will say, yes, I can do it better than whoever wrote this before, even if that person that wrote it before, it's us 5 years ago. So we have a tendency to want to do that, but usually it's not a bright idea for a lot of reasons. For example, you need to usually balance this with product work, right? You cannot tell your customers, okay, so for the next year, I won't do anything else because we're rewriting what we have. Okay, and what we'll have new in 1 year? Well, nothing, the same thing. It will just be easier for us. There's not something easier to sell to your customers. Or you need different teams to do this, right? If a new team handles new code, then you need a different team that handles the rewrite. And then if new features are added, you need to add them to the rewrite. And it gets complex and complex. If bugs are fixed, you need to make sure that's taken into account in both systems. So rewrite, it's not that easy, and we should try to avoid doing this as much as possible. That comes to the skill of writing code that's easier a bit to understand, so we'll try to avoid this kind of technical debt. Now we're going to look at a few things. It's not like a magic silver bullet. It's not do these 10 things and your code will be the easiest code to read in the whole world. There are just some basic things that I've seen while reading and writing code. They are relevant for me. That's why we are here. I'm trying to explain what I found relevant, and you can tell me after the talk if you think they are useful or if some of them you think are completely irrelevant. At the end, we're going to have a Q&A section, so you'll be able to ask any questions. Please hold on to your question. So let's go to the first of them, which seems simple enough: white space. White space is your friend, especially new lines. Nowadays, this problem was partly solved with formatters, right? Because we have pre-tier and other things that format your code. We're no longer disputable how we format them. But it doesn't usually add new lines. And I've seen so many code that's written in a way that the developer writing is afraid that if he hits enter, he will be fired. No new lines. You have 100 lines of code, no new lines between them. You can do other things with that code, but usually if you hit enter from time to time, it's not so bad. So this is something very simple. very easy. You can understand this code if you look at it a bit. By the way, all the examples are generated or random examples written by me. I've tried not to use like production code either from the component I'm working or from the internet because I don't want to use my own bad code as example all the time. So they are just for academic purposes. You understand what it does? It might be simple. Let's compare it with this. I don't know how much it helps you. I've just added 2 new lines. You can structure them however you want. I even feel more peaceful when I look at this. This one is like, okay, yeah, like I squint my eyes already. I have to understand what's happening here. And this is a trivial example, as I said, but you can imagine you're writing a React component. You have like states and hooks in the top. Maybe add a new line from time to time and group them somehow. We'll see what to do with them at some point. But until then, just remember that nothing will happen if you just hit enter twice from time to time. Another thing that took me a while to understand is that I don't get any awards for one-liners. There's I think a period in everyone's career where you learn something new and you're so excited that now you know how this thing works, and you have the tendency to maybe overuse it a bit. From my previous example, this was one of the lines. We use reduce, we create a score, then we use that score for something. Now this is pretty easy to understand, right? Because it's not that complex, but it uses reduce, which is not something trivial. You might be in a team with people that never used reduce. And it might be better for your team or for your future self if you write it in a simpler way. By simpler, I mean something like this. Yes, it takes a bit longer, and I know at the point where you learn how to use reduce and what it does, you're like I said, excited to use it. I've been through that. I've learned what reduce does, and then I was like, okay, I'm going to just reduce everything. If it's possible, I'm going to do it. I remember I've seen a conference talk like a lot of years ago, and the speaker at that point was arguing sort of like something similar, that even though you know how to use reduce, you shouldn't use it. And I was like, outraged. What do you mean? Everyone should just learn how to use reduce. Why shouldn't I use this? Well, fortunately, I think I'm a bit more considerate of my time and other people's time at this point. And whenever possible, I try to go for this one. And again, this is a trivial example. And there are cases where you can use reduce without any problem, but you don't need to overuse it, because simplicity is about clarity. The clearer and the easier the code is, it's helping you and your team to read it and to understand what you are doing there. And yeah, it helps everyone understand things easier, and it helps your teammates and future you. And I can give another example from the same part. Usually most of these examples are also things that I'm doing wrong or I did wrong, so don't imagine I'm not doing this. I think it was several years ago. I was working with Angular at that point, and I've learned about RxJS, programming with observables and streams, and it took me a while to understand everything. And man, I was so excited that I liked that library and the concept of working with streams so much that I was seeing streams everywhere. Like data streams, event streams, everything in the application was working with streams. I don't think Claudius here, a friend and ex-colleague of mine, so we worked for I think 2 or 3 months, and if it was streams and this like 50 lines of code processing those streams, and then we work on something else, and 6 months later we came back to that part and we were like, what on earth were we doing here? I mean, like, okay, I know we can use streams, but why did we use streams for everything? It's like, it's only streams now, because once you start with it, it's easy to, okay, I'll make this a stream also, and I combine it with the other one. So use it, but use it appropriately, and when it also makes sense. Another thing that you're also probably aware of, and that's quite, seems trivial, but you know, it's hard, is naming things. Because in some of the previous examples, like I think naming these variables differently would have gave you a lot more context about what's happening, right? You can do other things with this code to make it easier to understand or to read, but even just using proper names is way better than AV and ARR from array and X, I, Z, and so on. Yes, naming is hard, but we should at least try. And there are a few easy rules or guidelines. We should use descriptive and purpose-driven names. Like I said, no ARR, or I've even seen a lot of libraries that do this, like data, or my number, or things like that. It doesn't tell me anything. Even status without context, it doesn't tell me anything. So we should try at least to use something meaningful, even if we write a bit more characters. I know we're trying to write as few characters as possible sometimes, but please don't use, like, if you're not working with coordinates, don't use X for a variable name. It's not ideal for anyone. Another thing is avoid abbreviations and acronyms. I'm glad that a few of my colleagues from work are here, because I'm going to give an example that I'm hitting constantly these days. So we have AI in some parts of our application, right? We can generate some things using some AI models. And of course, in documentation and in code, we call that AI. Right? It's a good abbreviation for that. And then in other parts of the code, we have something that's called assignment ideas. Right? You can assign some things to students, and those are ideas. Well, guess how those abbreviated in code and in documentation? AI. And then in other parts of the code, I think we have something that's called assignment interactions. You can add some interactions on video. Again, they're abbreviated AI. So whenever I read a ticket in Jira, I'm like, okay, AI what? What I'm talking about here? And that's visible in the code also. I think we have components that are called AI review. I'm reviewing what? What does it mean? It's not hard just to add a few more characters there and give the context of what you are doing. So as much as possible, avoid abbreviations and acronyms. And the last one, just don't use weird names. I've seen all kinds. If you cannot pronounce it easily, try something else. It doesn't matter. Or even like I said, one-liners. I don't suppose I need to say it, but still I've seen examples. Please use English for your variable names. I've seen examples where they're like German or French or things like that. There will be other people that don't speak that language. Most of us understand English at least to a level where we can write code. I think it's decent to write the code or variable names in that language also. And this is a recommendation. It's a pretty old book, I think. It's called Code Complete. You have a lot of resources where you can learn about naming things properly. I usually recommend books that I've read. They have a full chapter, I think, about naming and why it's important. And that's the first book that I've read and left a mark for me, about how to name things. I still have it at home. If you want it, it's like this big. You can use it to protect yourself on the street if someone attacks you. And yeah, I know that today we don't necessarily have the time or the attention to read books, but I'm the type of guy that recommends books. So you'll see more of them in the next slides. Another thing about names is that I've encountered people that say or sustain that names are not important and they are not that relevant, and I can just use X and Y and whatever I want for variable names. And I would suggest to do a simple exercise with them. Take any class or anything you have and make them debug that code, but give them the minified version. Just see how it works. If they make any progress, leave them for 5 minutes, 10 minutes. Maybe you can figure out what this is doing because of the string, and they'll be able to debug it. So if they're making any progress, give them the same piece of code, but this time obfuscated. Right? So you take the code and you intentionally make it hard to read. This is the same code as before, but it's, I think it's a bit harder to understand. And after this, they should be able to understand why it's not that fun to name variables X and make it hard for everyone to understand what you are doing there. And since we're discussing about naming, let's move to comments. I don't think that everything needs to be commented. Usually, you don't need to add comments for all your code. This is a simple example. You get active users, and I have a comment like, look through the users array and return only users where active is true. Comment is there. It basically tells me what the code is doing. I'm not sure how useful it is. it reminds me of my first job when we were working in a code base, and there was a rule enforced that we had to add comments for everything, right? And this was like 15 years ago, so we didn't have Copilot and ChatGPT and things like that. And what we did was we found an extension for the IDE that we was using that was generating comments based on the names. So if my function was named getActiveUsers, it was adding a comment, this function fetches the active users, because it was mandatory to add comments for everything. Now, again, why that was useful, I have no idea. I have no idea for who it was useful. But I can show you another version that might work better. So this is the same function, but in this case, the comment says you only want to display users who are currently active, so we filter out inactive users to improve user experience and avoid confusion. This no longer explains what the code does necessarily, it explains why we do the thing that we do there. And again, this is a trivial example, just to prove something. Probably in reality, I wouldn't add a comment to a function called getActiveUsers. It should be easy enough to understand what it does. But whenever we feel the need to add comments, those comments should explain why we do the thing that we do there, not what. If I'm spending like 1 hour or half an hour or 3 hours and I write a class, a function, a component, whatever, 50 lines of code, and I feel the need to add the comment that explains what I'm doing, I don't think that's the ideal way of writing the code. The code should tell me what's it doing, not the comment above. So if I feel the need to add that comment, then I probably have a good chance to refactor the code in a way that's easier to read. And about reading, another recommendation is that you shouldn't force me to read when I'm looking at code. What do I mean by that? I think we have a lot of examples. I'm doing this probably a lot of the time. I have what looks like a simple if statement, but I have like 3, maybe 4 conditions inside the if, and then I do something. And when I read the code, first I need to figure out, okay, what's this condition doing? Because it's a combination of multiple things, instead of just figuring out what's happening inside the if. And what I can do here is like extract it locally in a variable with a good name. We just look at the names. Why is this helpful? Because then whenever I'm reading the code, this is how I see it. So initially, I don't care what that variable does. Why? Because the name tells me. I can look at the code from the if statement. If something doesn't work, or I need to change the variable, then I can go back and actually expand that and try to figure out what's happening. Your IDE or Visual Studio Code or whatever you're using probably even is allowing you to collapse things like that. So whenever you're reading code, you can actually hide it and it will show pretty much similarly to this. And why is it important? Because when we're reading code, we can, oh, sorry, I'll go back. It's just an image. Sorry for the white. Whenever we're reading code, we have a limited mental capacity to remember things and to keep things in our mind. And in order to understand the big picture and the whole thing, we need to manage to keep only the relevant things in there. If I need to figure out for every if statement what's doing, then I'll probably run out of mental capacity to hold on all to these things before I finish reading all the function or what's happening there. That's what this was doing. Sorry for it. Singular responsibility. This is another very linked thing. I think, Andre, you had a talk similar with about singular responsibility. I won't explain it too much. The thing is that whenever you're doing something like this and you're extracting it to a variable, a lot of the times you can extract it to another function or just move it somewhere else because it's doing way more things. And there are a few things that we looked at that will help you with this. So whenever you're adding comments, if you feel the need to group code together and add comments explaining, okay, these lines do this, it means that your function is already doing way too many things. You can take all that block of code and extract it in a different function. Or if you're doing the new line thing, and you're inside the function and you have 20 empty lines, it means you've grouped together so many things that you can probably extract some of them to their own functions. This is why I've mentioned it, and it's very powerful, used properly. And there's another thing. Whenever you extract code like this in variables and in other functions and in other classes, the code transforms in a way that it almost speaks to you. You know, it's not only if statements and you read the name of variables, you read the name of functions and classes, and it kind of tells you what's going on. Another very popular terms, don't repeat yourself, and let's call it, keep it simple and straightforward. What do I mean by this? I think that I've done it, I keep doing it a lot of times. Whenever I have to implement something, I'm already thinking, yes, so I'm a good developer, so I'm going to make this generic. I have only one use case, it doesn't matter, but I'm going to make it generic. Because in 3 weeks or 3 months, I have to come back and add a second use case, and I'll make it very easy for myself to add that second use case. And I'll make something that's complex, because it's generic, so it's a bit more complex than a simple use case, and that thing makes the code harder to read. And what happens in 3 weeks and 3 months? I'm trying to add my second use case, and I'm like, yeah, but whatever generic implementation I did, it doesn't work for my use case, so I need to rewrite it. And then I spend time again, and the code is complex to read from the beginning. And in a lot of these cases, the second use case will never come. So you've just added a lot of complexity, which makes the code harder to read for nothing, just because maybe at some point I'll need to add something else. As much as possible, we should avoid unnecessary abstractions. They are good, we know we can do them, but unless they are really needed, we should avoid them. And it's not a recommendation for myself. I've read this in countless places. Whenever you are trying to apply a principle like don't repeat yourself, you need to have code that repeats itself at least in 2 places, ideally 3. That's the point where you can make something generic. If you have only one use case, you're just gonna okay, I imagine I'm gonna have these use cases, and then it's nothing like what you imagine. So it's very okay to apply it, but wait until you have 2 use cases. You can even write the code, it's not a problem. You have 2 implementations, then you can really make something generic. And another thing that's somehow related to this, and again, it adds complexity, which makes our code harder to read. It's about over-engineering, which is a bit similar, but what I'm trying to say here is a lot of the time we're working on a new project, right, or a new product, or we're working for a startup, and yeah, we're not deployed to production yet, we don't have any customers yet or any users yet, but let's build this like we would have 100 million concurrent users and add all the components and all the infrastructure to support this. It's okay to think about it, you will have to do it at some point, but is it needed from the beginning? Probably not. Maybe you'll build something that will have success, but only 1,000 users. Do you need to worry for more and add all that complexity? Maybe not. And this is especially important, for example, if any of you work in startups, for example, because startups in the beginning, you're trying to find product market fit, right? You're trying to figure out what's the minimum product that I can sell it to a part of the market. And if you're spending a lot of time building this perfect solution that will work for a lot of customers, there will be 10 other startups that will build the same thing faster than you because they're not adding all that complexity from the beginning. Another thing that I've seen overly used and that adds a lot of complexity and makes things harder to read is about our tendency to use what we are biased towards, right? So for the first 10 years of my career, I wrote C# code or C++ code. And of course, I knew object-oriented programming. That's what I knew. When I went into web, of course, I went to Angular and TypeScript because I had to look at React and function. I was like, no, I have no idea what this is. I'm not going to do that. And then I see a lot of people that, for example, start working with React, nowadays React, with functional components, but they are trying to bring their concepts of object-oriented programming into it. And it's okay, but it's not ideal. And you make the code harder to read because you add all this complexity. It's okay to know both of them. I don't think object-oriented programming is perfect. I don't think functional programming is perfect. Just learn enough for both of them and apply when needed. So if you're working with React, try to think more functional because, right, the React component is a function. If you're working with Angular, try to apply a bit more object-oriented programming because you need classes and so on. Don't overly use any of these concepts. If you're like me and you have an OP background, I'm not sure if anyone is here, I recommend function like JavaScript. It's open source on GitHub, and it taught me a lot of things about functional programming and how to apply it in JavaScript. I've kept mentioning complexity because if we add complexity to our code, we make it harder to read. And that's a problem that we're trying to solve. There are different ways to measure complexity. For example, if you start a new project or look into a new module or anything like that, maybe one of the first things that you do is just like run a tool that counts the lines of code for different programming languages, like how much JavaScript I have, how much TypeScript I have, how much CSS I have. That gives you somehow an idea of what's there. Another way of measuring this complexity is about cyclomatic complexity. I'll try to very briefly and very shortly explain what it does in the next slide. I think most of your IDEs are able to show it. I know Visual Studio Code, and I think even IntelliJ. In Visual Studio Code, you have a lot of plugins that do that. One is called Code Metrics. In the next slides, I'll also show you how that looks. Basically, what this does is like it's a metric used to indicate your complexity, how number of paths you have in your source code in a specific function, for example, and it's represented by numbers in the implementation that I'm using. For example, this is a component. The complexity starts at 1. You don't need to have anything. Your component complexity will be 1, right? So then you add an if statement. Okay, we add more 1. Plus 1, complexity is 2. Another if, complexity is 3. Ternary operator, complexity is 4. A for loop is 5. Logical is 6. If one of the ifs, for example, had an else if, then it would be 7, and so on. And it tries to figure out what this number is for all the functions or classes, whatever you're using in your project. And I've made my ID or my editor show them. And that means that it's, sorry, something happened with, there we go. Sorry, this is the only white. I'll move it. If you look at the top, it says complexity is 7. It's time to do something, and it adds the yellow mark. In this one, it says the complexity is 13. You must be kidding, and it's red. You can configure the messages usually. You can configure the colors and so on. Now, I'm not enforcing this. I'm going back just to avoid white. I'm not enforcing this in any way. I've recommended to colleagues. It helps me when I write code to just look, okay, what's the number? Maybe I need to do something here. If you would want to do something even more interesting with this, it's like you can generate this complexity for all the files in your project and order them by this cyclomatic complexity. Is this useful? Maybe. You know which files have the highest number for this complexity. But we can add other metrics to make it even more interesting. So after this, you can order them by change frequency. You can get this from Git or whatever you're using. And now you have files that have a high complexity and are changed often. At this point, you have a pretty clear idea about which files might be problematic. Besides this, we can keep going with this. You can add files that have a low test coverage. So you have files that are high in complexity, change often, and have no tests. Well, you just found your next refactoring target, or what you can work on in your next tech dev sprint, or how they are called in your company. Okay, this was a bit of diversion on how you can use this to generate some metrics that are helpful for your project. Nowadays, we have to also discuss about different LLMs. We all use Copilot and ChatGPT and different kind of tools, and by no way I'm encouraging you not to use them. I use them daily, if not maybe weekly, but at least weekly. Why is this a problem? Because left unchecked, all of these tools, some of the time, I'm not saying that always, but some of the time will add unneeded complexity in your project. What do I mean by unneeded complexity? This is the version that at least 2 of them generated for me. I've told them just create me a counter component in React with a count and a double whenever the double changes, update the document title with that value. And you can see it uses two use states, one for the count, one for the double, and two use effects. This is code generated by an LLM. And then I was looking at it and I was like, yeah, but if I would write the code, I would probably use derived state and have just one use state and one use effect. And it's sort of like the same thing, but the complexity is not there. And this is one example. Other examples that I've seen is, for example, overly complex TypeScript types. You tell it to do something, it generates one of those types on 5 lines of code. And this is not ideal because you don't necessarily want to maintain complex code, right? So it solves your problem, you finish your task, but again, in 3 weeks, you'll have to change that type. Do you want to change it? Probably not. And it usually has this tendency of adding all these systems and unneeded complexity because that's how some of them train. This is, by the way, something that I've noticed at work. Again, my colleagues are here, they'll be able to correct me afterwards, but we've introduced Copilot a while ago, and for a long while I was trying to get us to use more advanced things from TypeScript. And now what's noticeable in some pull requests is that we've moved from basic types like number, ball, and stuff to like complex types, and like when did we got from the simple thing to this one? There was no middle ground, you know, and that's a bit one indication that it doesn't work ideally. Another funny example that I've seen with LLMs was when you are using set timeout, for example. You know that the return time for set timeout is different in Node from the web. If you tell an LLM to use code in TypeScript or to generate code that uses set timeout, it will generate something like, so the return type is type of, return type of set timeout because I don't know what it is. I know what it is. Our project only runs on the web. It doesn't run on Node. I can just write number there. I don't need this whole complex thing. So it's something simple, but left unchecked, it will keep adding more and more complexity to your code base. And these were some of the things that I've noted, and maybe we can ask ourselves, okay, what can I do? First is, okay, we need to check our code exactly like this with the LLM and whatever we're doing. It's a good thing that before you assign the pull request that you're creating to someone else, just do a review yourself, look over it and see what's happening there, what code you wrote. If it's possible in some cases or for large changes, what helps me is even to leave the pull request for the next day. Right, so I'm finishing up for today, I've created this draft pull request, I don't assign it to anyone. I come in the next day and I'm looking at it, because when I wrote it, I have all the context and everything in my mind, and the next day I'll just try to figure out, okay, is it this still understandable? Am I still able to easily read this code? If not, then maybe I can do something about it. Another fun thing is something called hallway usability testing. We can apply that to our code. It doesn't have to be a formal thing like creating the pull request or something. Just wrote a piece of code, it seems complex to you, or maybe it seems easy to understand, and you're trying to figure out if it is or not. One of your colleagues just passes by with a coffee and just hijacking. Like, come on, sit here, look at my code. Just read it for 2 minutes, tell me if you understand it or not. If he says not, maybe there are some things that we can do to improve it. Next part is, of course, we can check other people's code whenever we see this kind of complexity added, or ways that the code can be easier to read. We can add those things. Sometimes I think I'm trying to add like nitpick. You don't necessarily have to change this, but in my view, I think the code will be easier to read if we do this. Another thing about checking code or other people's code on pull request is that I strongly believe that whatever can be automated should be automated. So most of us use linters and formatters and so on, but sometimes we use them maybe just like a superficial level. For example, ESLint, which is what we're using, has rules for a lot of these things. For example, you can like show a warning or outright an error if it finds one letter variable names. or it can just tell you. You can add exceptions to that, so you can play with it. But a lot of these things need to be automated. Why? If it can be automated, you don't need to spend your time on doing this. Another good thing that you can do is to have a style guide. I've added 2 examples here. The link for Google, they have an internal style guide for at least, I think, 5 or 10 programming languages. They keep all of them there. You can look at it. This is the style guide for Angular. Now maybe one of you knows, I don't think React has something like that, because usually they try not to recommend something overly specific things. But you can have a simple style guide for your project. Again, if things from there can be automated, then they should be. But it should be something easier. Imagine that I'm joining your company now, and you're just sending me this link. Okay, here are 3 pages about how you write code around here. You can read that, and then you know that you will get less comments on your first pull request. And the most important part is, of course, we can grow ourselves. The biggest or the most relevant investment that we can make is in ourselves. And again, a few more books. Like I said, I don't recommend books that I haven't read. I've went through all of these: Art of Readable Code, Clean Code, and Pragmatic Programmer. I think I have at least these 2, again, printed at home. So if any of you wants to read them, just let me know, and I can share them with you. These were the resources and the few things that I think can help us write better code. We can move on to the questions, if I have any questions.
You made me make notes. So
I do the same thing because I forget. So.
Yeah, definitely. Okay, so some things on the new line side, I'm currently using a ESLint rule. It's a padding line between statements. So if you like that, and everybody, I really recommend that. With ESLint version 9, it moved to a different plugin for ESLint, but there is one.
We can still use it.
For the complexity, also there's that rule, so you can even do that. And now on the question size, you said use 4 instead of reduce in that case. Do you know on the performance if there is a performance for 4 or reduce, which one is better?
Usually,
because there is not just about the style guides, also about the performance, and there are kind of applications where this type of performance matters.
I completely agree with you. I'm not working on this kind of applications. I think most of us which write JavaScript don't work on those kind of applications. I've had this debate several times before. My response is that for us or for the projects where I've been involved, this doesn't matter.
Okay.
So, and all the time I'm optimizing the code for the people that read it, not for performance, but that's a very valid point. When I was writing, for example, I know C# or C++, we had cases where it was hard to read because it needed to be optimized for something very specific, and that was a good exception to the comment rule. Then we had comments with what the code does because it's hard to read.
Yeah.
But it's a valid point.
Actually, I was obsessed at some point years ago about the performance of loops. I can share a little bit. From the loops, the fastest is the classical for I equals, that's the fastest by any means. The map is the fastest you can get from the non-for loops. And the for in and for of, they are the least effective if you are looking for raw performance.
Okay. You said for the comments there was some time where those were required in your code. I also happened to work in the past with that, and for us it was required because based on the comments, the company was generating the documentation and providing that to the company that hired us.
Yeah,
so in outsourcing. So maybe that was also the case.
It is because it was a medical software.
Yeah.
So with blood analysis and so on. And like you're saying, the documentation for the application was like bigger than the source code itself, but that documentation didn't make any sense because we were using those kind of tools to generate
Okay,
stuff.
another question on the set timeout type. I also encountered this one, and I was curious if TypeScript fails with that, or you need to set something for the TypeScript on the tsconfig in order to say that it's only for the browser?
It depends what types you include, yes. So if you include only web APIs, then it will be the one for the browser. If you include no types, it will be, if you have both, it can be both. So
okay, because when I used it last time, it also complained to me this is not a valid type, and I needed to write also the node type. So I was.
It depends how you use it. If you want to get out of this, just use window.setType and set timeout.
Okay, and you said for the style guide there is nothing for React. I also don't know of anything official. I used in the past one from Airbnb. They had one from that's pretty maintained.
Yeah, it's good. I think there are a lot of good companies that create these style guides. And of course, if you want to create one for your project, the simplest way is just take one that's already created and update that one to your own liking.
I just wanted to add a book I've read in the past, which is not too big, and it's kind of related. It's called Philosophy of Software Design. You might like it.
I've heard about it. It's somewhere on my reading list, but my reading list is like, I don't know, 500 things, so I haven't got to it yet. But thank you, it's there.
I think I can work without microphones. Hello. So I wanted to ask you, you said that you use different LLMs in the team. Have you tried to pre-train the LLM with all these rules which you want to suggest to the team, and then check with the LLM, let's say, the cutoff date, and suggest the coding style, like the version of React and all that?
Not for coding. I have like a separate desktop application that I use in my ChatGPT, or in my case, Perplexity, and I had some custom rules for that one because I need it. I'm trying to make it be more direct. We haven't got so far with how we use LLMs, honestly. There was a point where different persons from the team, so I had my own subscription and trying something else, and other people had something else. I think we just rolled it out, I don't know, a few months ago, Copilot inside the company. We are working now on figuring out these kind of rules and examples on how we use it to make it more useful. But it's a very good idea. We don't do that.
I see. I'm a Java programmer, and I try to integrate with my Angular front-end dev. And I had very good results. I'm not using Copilot. I use GPT Team Plus. And after you train and you explain which is the Java version or Angular version, it starts to code exactly like you want, and it's giving you very good results. Yeah,
I imagine that if you have a style guide, irrelevant is from another comp from yours, you could also give it the style guide and tell it, this is how I want to write code. I don't know.
I can give an example. For example, I have one service developed, and I take all these classes, I put it there in the instructions, and then he starts to develop exactly like I did before.
Nice.
I suggest, yeah.
Thank you.
Thanks.